So here's a summary of the addition reactions that we examined so far in chapter 20 and chapter 21, related, of course, to aldehydes and ketones. So we said aldehydes are more reactive toward addition reactions than ketones. Talked about this in chapter 21, if you recall. Chapter 20, I mean. Where if we use Grignard reagents, organolithium, lithium aluminum hydride, etc., that these reactions are irreversible. You can't go back to the ketone or the aldehyde. However, we did talk about reactions in this chapter, in chapter 21, that are reversible. And it was the hydration reaction. It was the formation of the hemiacetal or acetal formation. You can use even a sulfur, a sulfide, as to add amine, cyanide addition, etc. So these reactions, we said, are reversible. In basic media, meaning, you can use hydrolysis and go back to what you started with, go back to the ketone or the aldehyde. In basic media or base catalyzed, recall that we have a good nucleophile or a strong nucleophile. We saw that the attack happens first. So this is an important pattern. We have a nucleophile. The nucleophile attacks first. You form the O minus, and then we talked about protonation happens next, followed by protonation, etc. In acidic media, we said the carbonyl is protonated first. We have hydronium ion. So this is an important pattern for you to recognize the difference between acid catalyzed and base catalyzed reactions. So you form the protonated carbonyl. Which is more electrophilic. So then this is followed by weak nucleophile attack. Or attack of the weak nucleophile. It was the water, the alcohol, etc. However, we just talked about the exceptions in imine and enamine. We talked about at pH of 5, that ensures that protonation doesn't happen, and the nucleophile attacks first. So it's sort of like the base catalyzed mechanism, but in an acidic media. So that's a distinction we would like to make here. So make sure you're aware of those mechanism differences. The next reaction is, it seems like it's under a